Welcome back, students. In this video, we're going to cover Module 7, Topic 2, Parallelograms. In class, we'll do both Topic 2 and Topic 3 together in the same day, but I'm going to split these into two videos because I'm just trying to keep videos a little shorter this semester. So, this is page 5 of the Module 7 packet. There's your standards and the objective. We're going to go ahead straight into the warm-up. I've already taken the time to color code these our angles over here based on our problem. It says in the figure, parallel lines M and N are cut by transversals S and T. Right, true, or false? So, the first one here is angle 6 is congruent to angle 1. So, these two guys are parallel. The pink and the blue, I kind of messed up down here. It has to do with the top part. The orange and green are more for this because both lines are parallel in this problem. But for this here, 6 and 1, the congruent ones are going to have the same color. So we're pink here, we're blue here, so we're not congruent. So that's going to be false. And the reason it's false, so these two guys being parallel, this is exterior, so 1 and 8 are congruent. This should be pink here. These across from each other are going to be congruent, both sides, so that makes 7 and 6 are both blue, so that's why I'm blue and pink. Hopefully that made sense. You have to... We can go back and have other videos covering this a little better, but I'm trying to go through this kind of quick. All right, number 2. So 11 and 12. I'm sorry, 12 and 13, excuse me. So let's see. I didn't mark these with the blue and the pink, but so if we're pink, see, I messed up over there, so let's see. Actually, 12 and 13. These are both interior and they're alternate sides, so they are congruent, so that's true. All right, it says 4 and 11 are supplementary. So 4 and 11, notice those are interior and consecutive. Well, they're not interior. Yeah, they are inside M and N, and they are consecutive, so that also is true. Now, number 4, are 6 and 15 congruent? So 6 is green, 15 is green. If these are all parallel, these are interior, and they're alternate, so they are congruent. That's true. 4 and 13. So 4 is orange, 13. Those are interior, alternate interior as well, so those are true. Or that is true, excuse me. And then for number 6, 4 and 11 are supplementary, and again, that's true. All right, so let's scoot up here. Properties of quadrilaterals. Now we're going to talk about parallelogram first. One second. All right, so properties of quadrilaterals. A parallelogram is a quadrilateral with both pair of opposite sides parallel. So B and C and A and D over here for this example. And then AB and CD or DC. To name a parallelogram, use the symbol, and you can see here. And so in parallelogram ABCD, BC and AD are parallel. So BC, AD, and then AB and DC. AB, DC. And that's the extra arrow in the middle, or 2 arrows, that tells us that these two are parallel, these two are parallel. All right, theorem 7.3. If a quadrilateral is a parallelogram, then the opposite sides are congruent. Theorem 7.4. If a quadrilateral is a parallelogram, then the opposite angles are congruent. Theorem 7.5. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. And then finally, 7.6, if a parallelogram has one right angle, it has 4 right angles. And that is true. So, moving down. Number 1. Find the missing sides and angle measures for the quadrilateral. So, we know opposite sides and opposite angles are congruent. So, we just need to... So, this side is 45. This side's 45. This side's 4. That side's 4. This side's 1.5. This side's 1.5. Just put feet so there's no confusion. Excuse me. And we also know that the consecutive angles are supplementary. Supplementary means they equal 180. So if this guy's 45, the one across from it, 180 minus 45 is 135 degrees. And of course, opposite angles are congruent, so that makes this 135. And then, of course, 135 and 45 equal 180. So there you go. Number 2, same thing. Missing sides, measurements, opposite sides are congruent. So if this side's 8 inches, this side's 8 inches. If this side's 3.6 inches, this side is 3.6 inches. 106 degrees, 106 degrees. Opposite or consecutive or supplementary. 180 minus 106 is 74. And then opposite angles, so this one's 74. So easy, see, easy peasy. No problem. So now, I'm going to do it without a, excuse me, without the drawing. So we'll draw it ourselves, but in parallelogram WXYZ. So A, B, C, D, W, X, Y, Z. We'll just draw this little guy in here. So it says if the measure of angle W is 48 degrees, I'm going to do this. Then what's the measure of angle Z? So Z is opposite of W. So if the measure of angle W is 48 degrees, the measure of angle Z is 48 degrees. Okay. Number 4, parallelogram WXYZ. WXYZ. If angle X is 17 degrees, what is angle Z? Well, X and Z here are going to be supplementary. So 180 minus 17 is going to give us 153 degrees. So angle, the measure of angle Z equals 153 degrees. Okay, let's flip over. All right, a little more information here. Diagonals. It says or, but it should be of parallelogram. So, pardon that. Diagonals of parallelogram. So, theorem 7.7. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So over here, if they bisect each other, this is half. Two equal pieces. Theorem 7.8. If a quadrilateral is a parallelogram, then each diagonal separates a parallelogram into two congruent triangles. Okay, yeah. So if you split it this way, you would have this side is congruent and this side, and then down here the same thing. All right, so number 5. Find the values of W and Z in parallelogram ABCD. If the measure of angle ADC is 4x, ADC, let's see, is 4x, so 4x, and the measure of angle DAB, so that's this whole guy here, is 2x minus 6. Okay, so part 1, find the value of x. So we're talking, I know we have the diagonals here. And the z, the diagonal bisects each other. So we're going to put z equal to z down here. I'm just going to go ahead and write that. 3z minus 4 is going to equal z plus 5 because they bisect each other. Now the angles, these two guys are consecutive. So 2x minus 6 plus 4x. So both of those angles together are supplementary, or they equal 180. Okay, so let's solve for x and then solve for z. Change colors here. Stuff's rolling over here. All right, so 2x and 4x make 6x. Minus 6 equals 180. Add 6 to both sides. We're going to just move up here. 6x, those cancel. 180 plus 6 is 186. Divide both sides by 6. And let's see. Yeah, 186. And x is going to equal 31. Now, down here, z's, let's just subtract z from both sides. These cancel. 3 minus 1 is 2z. Minus 4 equals 5. So we're going to add 4 because it's negative 4 there to both sides. Move this over here. 2z. What did I forget? Subtracted. Okay, yeah. All right, never mind that. So, making sure, all right, minus 4 plus 5. Yeah, add the 4 to both sides. So we're going to get 2z is equal to 9. Divide both sides by 2. So z is 9 halves, or 4.5. Okay. All right, let's scooch over here. Change color pens again so I can keep it separate there. So find the value of a and b in parallelogram STVW. So remember, opposite sides are congruent. So, and remember, I've told you guys every time we have A's and B's, we're going to solve separate here. So you're going to put, so find the value of A. A is going to be A plus 15 equals 3A plus 11. So let's just subtract A from both sides. Got our 15. 3A minus A is 2A plus 11. So I'm going to scooch up here. We're going to subtract 11 from both sides. 15 minus 11 is 4. Equals 2A. Divide both sides by 2. A is going to equal 2. So use the green down. Actually, let's just go back to red. So our B's. 3B plus 5 equals B plus 11. Subtract the B's. 2B plus 5 equals 11. Subtract the 5's. 2B, or not 2B, equals, so 11 minus 5 is 6. Divide both sides by 2. B is going to equal 3. All right, scooch down here. Okay, bottom of the page. Got a proof here. First proof of Module 7. Complete two-column proof. We're given that parallelogram JKLM, and we're given that KN, so let's do this, KN and KL are congruent. So now let's see what we've got here. We want to prove that angle J is congruent to KNL, so that these two are congruent. All right, got a word bank here. Sorry, we're a little sideways. There, sorry. Okay, so parallelogram JKLM, and KM is congruent to KL. That was given. Number 2, blank. If a quadrilateral is a parallelogram, its opposite angles are congruent. Well, let's see. So opposite angles are congruent. That would put, and that's not in the word bank, but this guy. So these two would be congruent. And we can go ahead and mark this. I mean, we know Opposite angles are congruent. And that's really what I want you guys to get in a habit of. So I know that these two sides are congruent. I know these things because we've learned these things about a parallelogram just in the last couple of pages. I should have made that blue, dang it. I messed up. Sorry. Because these two are congruent. We'll just make the little pink one too. So, sorry. The confusion. Now, so, if a quadrilateral is a parallelogram, then opposite angles are congruent. So here, J and L. Again, this should have been in the word bank, but it's okay. This will help us learn a little bit. All right, number 3, isosceles triangle theorem. Well, we know isosceles triangle, these two guys are congruent. So, let's see. If these two are congruent, then these two angles are congruent. So that would be angle L is congruent to angle N. Or KNL. Again, the word bank would help. So if L is congruent to KNL and J and L are congruent, then J is congruent to this guy because of the transitive property. Meaning, like we heard, so because J and L are congruent, and because L and K and L are congruent, then if these two are congruent and these two are congruent, then these two have to be congruent. That's the A plus B or A, C, we've talked about before in class. I'm going to hush before I confuse me and everybody else. So this concludes topic 2 for module 7. Have any questions, let me know in class. Until next time, have a great night.